Hey everybody, week 3 of Math Club. I'm so impressed with how you all are doing with this program. I hope you're enjoying it and having fun. I know that I am, and I love seeing your all's awesome work. As always, let me know if you have any questions. This week we are going to be working on multiplication and division, doing some review there and some practice. So this should be good as you will need all of these skills at a basic level for 4th grade, and then you will build on them. So we want to make sure that these are concrete and you all are comfortable with them, comfortable with the strategies, and then you should be ready to rock and roll for 4th grade. So let's dive right in. Our quote of the week: mistakes are proof that you are trying. So sometime this week you might have a hard time working on some of these math problems, hard time with the sport you're playing. Making mistakes is not a bad thing. That's actually a good thing. So that shows you're trying and you're learning and you're trying to get better. So keep that in mind as we dive in to multiplication and division. We're going to start with some multiplication vocabulary. So you all remember from 3rd grade that a factor times a factor is equal to a product. Okay. So what is a factor? A factor is a number that you multiply with another number to get a product. So those are just kind of vocabulary words that we need to know. Factors are numbers that you multiply together to get a product. The product is the answer to a multiplication problem. So I repeat this in my classroom: the product is the answer to a multiplication problem, just to get that vocabulary in your brain. Okay, so keep those things on the forefront of your mind as we move on to some multiplication main ideas. So the main idea for multiplication is that we are working with equal groups. Anytime you're multiplying something, you have equal groups. You have a certain number of groups and a certain number of objects in each group. So those are what we are working with. We want those equal groups to find our product, which is the total number of objects that we are counting. So multiplication is really just an easier way of us counting. What I like to do is think about a picture in my mind. Like if I'm trying to figure out if I need to add, subtract, multiply, or divide, what does that image look like in my brain? Are there equal groups? Are we having, if there's something where each person has 2 pencils and we want to know how many total number of pencils there are, I know that's going to be a multiplication, because I'm thinking, okay, if Johnny has 2, if Susie has 2 pencils, if Lee has 2 pencils, if Ellen has 2 pencils, they're going 2 plus 2 plus 2, 2 each. We got 2, oh, hang on, we got 2 here, we got 2 here, put 2 here, 2 here. Well, I've got how many groups of 2? 1, 2, 3, 4. 4 groups of 2, might be 8 pencils if we were using that as an example. So pictures are very helpful for multiplication. So let's look at this one. It says if there are 3 cans of pencils on a table in the art room, and there are 4 tables in the art room, how many cans of pencils are there? So let's draw a picture. So there are 3 cans of pencils on a table. Okay. And it says there are 4 tables. So we're going to draw, there's 1 table, 2, 3, 4. And there are 3 cans. So I'm going to draw 3 cans on each table of pencils. It didn't say how many were in each can. We just want to know how many are on the table when it said 3. So 1, 2, 3. There's pencils in there. So this picture helps us out. 1, 2, 3. So the question says, how many cans of pencils are there? Well, we can see here that, well, there's 3 there, 3 there, 3 on that table, and 3 on that table. So we can add 3 plus 3 plus 3 plus 3 plus 1, 2, 3, 4. 4 groups of 3, 3 in each group. So we can skip count. 3 plus 3 is 6, right? And then 6 plus this 3 is 9. And then 9 plus this 3 is equal to 12. So we know that there are 12 cans of pencils. That's just an example. Pictures are good. Some of you all might have that memorized, but if you don't, draw a picture. It's helpful. So you all learned in 3rd grade that there are different ways to solve multiplication problems. The first one, which is probably going to be the most beneficial long term, is just to memorize the facts. We worked on a lot of fluency, memorizing. A lot of y'all took all the tests and stuff and did it awesome. But just to kind of refresh and review on those is going to be very important over the summer to get prepared for 4th grade, because they're kind of going to expect you to memorize those and have them memorized for the math that you're going to do in 4th grade. So if you haven't done that, I would suggest that you can get flashcards at the Dollar General or Walmart or online. That would be a good thing to do. But if you don't have those, if you don't have some of your facts memorized, no worries. We can figure them out. We can figure all of them out. And what I want you all to be comfortable with is a strategy where you can take any multiplication problem and figure it out. So we talked about memorization, repeated addition. We can do that. That's just where, like I did on the other page, where you had 3 plus 3 plus 3 plus 3. And that's the same thing. It's equal to 4 times 3 or 3 times 4. They're equal. Find the multiples. What I like about this, and I think I'm going to give you all some examples there. Finding the multiples is really just skip counting by one of the factors. And if you do that, you will figure out the product, because you'll come across it. And I'll show you how to do that. You can draw a picture, and then we can build an array. So we're going to do 3 times 4. That's going to be our problem of the evening. So I did skip counting over there, but or repeated addition, but I'll put it down again. So that would be 3 plus 3 plus 3 plus 3, and that's equal to 3 times 4. Because of the commutative property, we also know that we could flip that. This could also be 4 times 3, right? And we could do 4 plus 4 plus 4, and that's also equal to 3 times 4, which is equal to 4 times 3. They're all equivalent. They all equal the same thing. I also talked about finding, what did I do? What did I put next? Repeated addition, finding the multiple. Some people like to do this. So if we look at 3 times 4, we're going to pick one of the factors. It doesn't matter which one. So let's start with 3. I'll show you both ways. We're going to list the multiples. So we're just going to skip count starting at 3, because 3 times 1 is equal to 3, right? So and then we've got, so 3, skip count by 3, 6, but we know that 3 times 2 is equal to 6, because 3 plus 3 is 6. So 3, 6, 9. So if we have 3 times 1, 3 times 2, that's going to be 3 times 3. And then our next multiple, so 3, 6, 9, 9 plus 3, so 9, put 9 in your head, 10, 11, 12, 3 more, so 9 times, or 3, 6, 9, 12, so 3 times 4 is equal to 12. So that's what we wanted, right? So 3 times 4, so I'm going to circle that. So we know that 3 times 4 is equal to 12. If we were going to do the multiples of 4, you would start with 4 times 1. So 4, and then I'm going to skip count by 4. So 4, 8, because 4 plus 4 is 8. So that would be 4 times 2. And then 4, 8, and then plus 8 plus 4 more is 12. So that would be 4 times 3. So that's what we wanted, right? 4 times 3 is 12. So that's how that works both ways. This is a good strategy, and I think one that's going to be very efficient if you don't have the facts memorized, and would be good for you all to use in 4th grade if you can practice this. That would be great. Like I said, we can draw a picture. If we did 3 times 4, we can do 3 groups. You can do just circles, 3 if we want to. 3 groups, 1, 2, 3, 4 tallies in each group. 1, 2, 3, 4, 1, 2, 3, 4. And I can do 1, 2, 3, 4, 5, 6, 7, 8. If we count here, so 8 here, and then going on over to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 4 there. So 8 plus 4 equals 12. Same idea. You can just count all the tallies up. That's going to be a way that might produce errors if you forget a tally or don't pay attention or not neat. I would like for us to progress from this one to one of these if possible, but I understand that we want to be comfortable and get the right answer. The picture drawing like that also takes a long time, but if you need to do it, that's what you need to do. And then the last one I was going to talk about is just the array. We use arrays a lot. Let's say I wanted to draw an array with 3 times 4. I know that 3, that means I have 3 rows, 1. So 1 row, 2, 3, and there are going to be 4 objects in each row. So I'm going to use X's. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So if I count, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you can skip count by 4s and just go 4, 8, 12. It all works the same. So those are just different ways we can represent multiplication that I wanted to show you. Now we're going to move on to division. So division vocabulary. Remember, we have a dividend. We have a dividend there, which is this number. The dividend is, if we're thinking real world scenarios, is the total number of objects. Let's say I have a box of paper clips. Let's say I have a box of 40 paper clips, and I have 8 students in my classroom that need paper clips, and I want to distribute them equally. How many are they each going to get? So the dividend is your big number. It's the total number of objects. So total number, that's an abbreviation of for number of objects. You all know that as a hashtag, but it can also represent the word number. My divisor is the number of groups. So if we use that scenario of paper clips and I have 8 students, each student would be a group, right? So I would have 8 students, so I had 8 groups. And then how many paper clips would each of them get? They get 5. That's because 40 divided by 8 equals 5. But this is the number of objects in each group. Depending on the type of question, it could also, these roles could be flip-flopped. you could have the number of objects in each group as your divisor, and you're needing to find the number of groups. That does happen, but know that you solve the problem the same way. Okay, just keep that in mind. So we have the dividend, the total number of objects. The divisor here is the number of groups, or it could be the number of objects in each group, depending on how the question is worded. And then you have the quotient, which is the answer to a division problem, and also it is the number of objects in each group. So if you see a problem that says find the quotient, you know that's going to be a division problem. So find the product is going to be a multiplication problem. Find the quotient is going to be a division problem. Let's look at our main ideas for division. The dividend, you're going to start out with the total number of objects when you have, for the most part, a division problem. That's your dividend. We want to find out the number in each group or the number of groups. Think about this. The quotient is not going to be bigger than the dividend. It could be the same number if something is divided by 1. So if I had 20 divided by 1 equals what? I know that I have 20 objects and I have one group. So if I have one group, I have one box of paper clips, and there are 20 there. Well, there's 20 paper clips in one group, so that's going to be equal to 20, right? So 20, any number divided by 1 is going to be whatever the dividend is. But you're never going to have a quotient, which is the answer to a division problem, that's going to be bigger than the dividend right now. In higher math, yes, but not right now. We want to keep it, if your quotient is bigger than the dividend, something is wrong. Okay, so just keep that in mind. Right now, anyway. In 3rd, 4th grade math, your dividend is going to be bigger than the quotient. Also, we want to use multiplication to help us solve. So multiplication we learned first. Multiplication facts seem easier to kind of understand and learn. So we want to use those facts to help us. Multiplication and division are related, similarly to how addition and subtraction are related. Okay, so I'm going to show you a fact family in just a minute with multiplication and division, but we're going to do this example first. We're going to use our same problem here. 12 divided by 4 equals. So I'm going to show you an example of how we can solve this. So 12 divided by 4, let's just do the basic way. A lot of you all learned this way. We're going to make 4 groups. Let me rewrite the problem. So 12 divided by 4 equals something. Okay. So 12, that's our total number of objects. And 4 is our number of groups. We don't know how many objects are in each group yet. So how we figure that out is we're going to put one object in each group until we get to 12. That will help keep it equal. It's not a good idea to try to put, I'm going to put 3 here and 3 here and 2 here. That's not a good strategy. You will mess up on doing it that way. This way we know we're going to have the same number of objects in each group. So this is a good way to do it. So let's just start. We're going to start at 1. We're going to count to 12. We're going to put one object in each group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now I stop. Is that my answer? No. Now I need to look specifically at one of my groups to see how many objects are in each group. So I see that there's 3 there. Now I'm going to look at all of them just to double check. So I'm going to look at this one. There's 3 there. I'm going to look at this one. There are 3 in that one. Look here. 3 there. So now I can see that they are all equal groups, that I haven't made any mistakes. So I know that 12 divided by 4 is equal to 3. That's the way to do that if you do not know the multiplication fact family. If you saw this, the way we could use multiplication to help us is to go, well, 4, so right here, 4 times something is equal to 12, because we know that 12 is our total number of objects. And in multiplication, we are wanting to know the total number of objects. So if we if we looked at that way, if you knew that 4 times 3 equals 12, you could just fill in the blank. But you could also make groups of 4 until you got to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 1, 2, 3 groups of 12. That's another way to look at it. Let's discuss the relationship between multiplication and division briefly. I know y'all have done fact families a lot with addition and subtraction and multiplication and division this year. So let's just think about a fact family here. So if I have factors of 3 and 4, that means that 3 times 4 is equal to something. 4 times because of the commutative property, we know that these are interchangeable. You can flip them. So we know that 3 times 4 equals 12. So 4 times 3 equals 12. Now the division, you just kind of go backwards. If I'm looking this way, you're going to go 12 divided by 4 equals 3. So I'm going to write that down. 12 divided by 4 equals 3. Now I want you all to think about what this last related fact might be. It's not a turnaround fact because we can't turn around these numbers. We can do it with the multiplication ones, but we cannot do it with division. So that's why they are called related facts and not turnaround facts. So think about that. Let me give you a hint. If you look at this one, you're just going to go backwards again. So I'm going to go 12 divided by 3 is equal to 4. Let's look at an array. So if I have a 3 by 4 array, and I want to divide it up into groups, equal groups, well, it's pretty easy to see that there are 3 groups. Each one's going to have 4 in each group. We can do our circles again, but we've already done that. We know that if there are 3 groups, there are 4 in each group. If there are 4 groups, how many are in each group? 3. So there's the relationship between multiplication and division. They are opposites. They are opposites, but they help each other, and they will make your life better if you understand that. Got a few word problems for us, and then I'm going to set you off on your way. You all have been doing great. Thanks for being patient with me. So let's look at this word problem. A store owner was buying uniforms for their employees. If each of their 3 stores needed 8 uniforms, how many uniforms would they need? So let's think about this. A store owner was buying uniforms for their employees. If each of their 3 stores, that's important, needed 8 uniforms, how many uniforms would they need? So let's draw a picture. 3 stores, so I'm going to do some stores. This will be store 1. That's an R, not a V. Store 2. And store 3. So there are 3 stores and they need 8 uniforms. So there are 8 here, 8 here, and 8 here. How many uniforms would they need? So I want you all to think, are we doing multiplication or division? I think I kind of gave it away there, but let's think about what would my equation be? Am I looking for how many groups of uniforms, or am I looking for how many total uniforms? So if you're thinking I'm looking for the total number of uniforms, because this says how many uniforms would they need, you are correct. So I have 3 stores, and they need 8 uniforms at each store. So 3 times 8. So you might have this memorized, and if you do, that's great. If you don't, what looks natural here? What if I put just a plus sign in between both of these? Does it look like repeated addition? I think so. So 8 plus 8, can be 16. And then I haven't used yet, so I'm going to bring this plus sign down. So 16 plus, and then when this 8, so I'm going to do 16 plus 8. 6 plus 8, 14. Regroup, 24. So how many uniforms would they need? So in a word problem, we need to write our sentence. Okay, so you would say they would need, just restate the question. So they would need 24 uniforms for their employees. And that's a good explanation. So make sure you're always writing explanations. You all did awesome this week explaining your work. Very proud of you guys for that. So that was a one-step problem. That was a one-step multiplication problem. There are different ways you can solve that. This was the way that I chose to do repeated addition, and that's totally fine. If you have it memorized, that's awesome. If you want to check your work, if you think you have it memorized, that's even better, because we want to check our work and make sure we haven't made any mistakes. Now we're going to talk about a multi-step problem. And that says, while playing basketball, Team A scored 16 points. 16 points. If each person scored 4 points, how many people were playing? So let's think about this. While playing basketball, Team A scored 16 points. So we have 16 total points. If each person scored 4 points, how many people were playing? So, 16 total points. Each person scored 4 points. How many people were playing? So in this case, we know that each person, we don't know how many people there are yet, but we know that we have 16 total points, and each of those people playing scored 4 points each. So we're going to do it's going to be a division problem, because we have our total number of points and we want to know how many groups we have. So 16 divided by 4, which is the number of points they scored each. We want to know how many players there are. So what I'm going to do to solve this one, I'm going to make points groups of 4 and see how many groups of 4 to represent players it takes to get to 16. So really what we're trying to figure out is 4 times what equals 16, okay? So if we got 1, 2, 3, 4, so there's one group, one person, one player. 5, 6, 7, 8, there's another player. 9, 10, 11, 12, is another player. 13, 14, 15, 16. And that's the magic number because we know there were 16 total points. So player 1 had 4 points. Player 2 had 4 points. Player 3 had 4 points. And then player 4 had 4 points. So we know that 4 times 4 is equal to 16. So 16 divided by 4 is equal to 4. We could also, to add another layer to that, we could say, well, what happens if Team A doubled their points the next game? Right? We could add that in. So what happens if Team A doubles their score the next game? How many points? How many points did they score? So doubling just means whatever the number is, do it twice. So if they scored 16 points this time, to double it, you're just going to do 16 plus 16, but in a multiplication sense, we know that that is what? 16 times 2. So if you don't know what 16 times 2 is, well, let's just rewrite it. Let's rewrite our 16 plus 16 that we wrote this way. We could just do 16, 16, add them together. 6 plus 6 is 12. 1 plus 1 plus 1 is 3. 32. So 16 times 2 is 32. So your sentence would say, if they double their score doubles, they will score 32 points, abbreviated points. Okay, that's a good, doubling is an important word to know with multiplication. It's just that's just times 2. Okay, so friends, I'm going to put some problems on your assignment that I want you all to read carefully, work through. Some of these word problems might be challenging because I think you're ready for them. Okay, I think you're ready for them. This was just a basic overview. Keep these examples in your mind. Keep the strategies in your brains. Work them out. If you have any questions, let me know. I'm happy to help. And we should be ready to rock, and y'all should be good to go. Let me know if you're having any troubles. I'm here. You can send me an email. And good luck. I think it'll be great. I'm going to leave you all with this. Have a great week. Some people say, find x if we want to solve. This is algebra with some trigonometry here, but kind of a cute little picture. So find x, they say, here it is. So you all may have seen that before. Your parents might see it, think it's funny. So I liked it. Have a great week. You all can do this. Let me know if you have any questions. Bye.